All right, and we're back with video 2. So, I forget to check the times on these videos, and I just keep talking after the 15 minutes has stopped. So, I need to jump back up here. We weren't done interpreting this linear regression line. So, we talked about the y-intercept and how it has no meaning in this context, right? But let's talk about the slope. So, it's a negative slope, meaning we have a negative relationship. As the x variable goes up, the y variable goes down. Let's see if that makes sense. Our x variable is how dense the stone is. So as the stone gets denser or thicker, then my cutting depth goes down, which makes sense, right? If I have a thicker stone, I'll be able to cut through it less easily, right? So as my stone density goes up, my cutting depth decreases by 133 millimeters. All right. Now this AP practice problem that I started on my own, talking to myself, I want you to pause it, give it a shot on your own, and then come back. All right, you're back. So, consider n pairs of numbers. So n is just the number in your data set, right? It's just saying we have a data set. Suppose x bar is 2, meaning the mean of the x variables is 2. S sub x is 3, meaning our standard deviation of our x variables is 3. Y bar is 4, and S sub y is 5. Of the following, which could be the least squared regression line? Which could be? That wording is interesting. All right, so I know I have an x bar and a y bar, right? So x bar, y bar has to be on my least squared regression line. It must. So I plugged in 2 for my x bar and 4 for my y bar. So automatically I know that this point needs to be on one of these lines. How do I figure it out? I plug the points in and see what works. So we'll be able to eliminate a few answer choices this way. So I take, this is A, right? Answer choice A. So if I plug in 4 and 2, 4 and for y, plus 2. So let's see, what is negative 2 plus 2? 4 does not equal 0, so A is not an option. All right, let's try answer choice B. Y hat equals 2x. I'm going to plug in 4 and 2 times 2. Does 4 equal 4? It does. So B could be a contender. I'll mark that there. All right, C. Y hat equals negative 2 plus 3x. I'm going to plug in x bar and y bar because I know that this point has to be on my least squared regression line. So 4 equals negative 2 plus 3 times 2. So 4 equals negative 2 plus 6. Negative 2 plus 6 is indeed 4. So C is also a possibility. All right, let's try answer choice D. Y hat equals 5 over 3 minus x. Oh my gosh, why did I write that? So 4 is going to equal 5 over 3 minus 2. Alpha y equals enter gives me the fraction 5 over 3 minus 2. I get negative 1/3. 4 does not equal negative 1/3, so I can eliminate D. Let's see, answer choice E. Y hat equals 6 minus x. I'm going to plug in 4 and 6 minus 2. 4 does equal 4. So now I've narrowed it down to 3 possible choices. So let's see what other information they give us. They gave us the standard deviation of x and the standard deviation of y. Can we think of a formula that we just learned that involves that? I can. And it's the slope. Ooh, excuse me, got choked up. LSRLs get me so emotional. All right, the slope is going to be the correlation multiplied by s sub y over s sub x. That's our slope formula that we just learned. All right, so I have s sub y and I have s sub x, but they didn't give me correlation, right? So I know that my slope is going to be correlation, whatever my correlation is, multiplied by 5 over 3. All right, well now I'm stuck. What in the heck do I do? What do you know about correlation? Think, what are your main ideas? What could correlation be? Could correlation be 100? I hope you are shaking your head no. because you know that correlation, R, has to be less than or equal to 1 and greater than or equal to -1, right? The lowest correlation I can have is -1, which gives me a perfect negative correlation, and the largest correlation I can have is a +1, right? So, if these are my only options, I can calculate a range of what my slope should be in, right? So my low range, if I plugged in -1, I know that my slope could be -1 times 5/3, which would give me -5/3. Or my high range of the slope would be 1 times 5/3, which would give me a +5/3. So I know that my slope has to be between -5/3 and 5/3. Let's look at the slopes that I have left. For B, it's 2, right? The number in front of x. For C, it's +3, the number in front of x. And for E, it's -1, that number in front of x. So of these three numbers, what fits in my range? Well, let's convert 5/3 into a decimal. We get 1.67. So -1.67 all the way up to +1.67. Does 2 fall within that range? It does not. It's greater than the high end, right? So I'm going to eliminate B. Does 3 fall in that range? Nope, it does not. It's higher than the highest it could be. So let's take out C. Does -1 fall in this range? It does. It's between +1.67 and -1.67. So it's my only plausible answer. E is my only plausible answer. Now it's definitely not for sure because I don't know correlation, right? But I can only do a best guess, and it's which of these equations could be the least squared regression line. All right. Flip the page over. We are now going to talk about, if I can get my camera, there we go, residual plots. So we learned the concept of residual last packet. So residual is your actual minus your predicted value, right? So your actual minus your predicted. So a residual plot would be plotting your residuals, right? So it's a scatter plot that displays the residuals on the vertical axis and the explanatory variable on the horizontal axis. So your residuals are here and your explanatory variables are here, right? Okay, so residual plots help us to determine whether the regression model is appropriate or not. So our regression model takes what kind of form? It takes a linear form. Remember, our regression model is LSRL, our least squared regression line. That last L stands for line, right? So our model is a linear model. Now, sometimes linear models are not appropriate for every data set, right? Only if the scatter plot forms a line would that mean that a linear model is appropriate. So our residual plots help us to determine whether or not a linear model is appropriate. So I want my residual plot to look random. If there is no leftover curve pattern, then my regression model is appropriate. If I do have a leftover curve pattern in the residual plot, I need to consider a different regression model. I can't use a linear regression model. All right, so let's take a look. Here is a least squared regression line, and we see it takes the form of a linear model. So when I actually plot these residuals, do you see how half of the values are on one side of the line and half the values are in the other? So when I do my actual minus my predicted, I'm going to have a random scattering of residuals, right? Everything up top here is going to have a positive residual, meaning my actual minus my predicted gives me a positive number and will be plotted on the top part, right? Here's the line here. It'll be above 0, positive. Everything below the line, my actual is less than my predicted, right? Because if you think about it, the model is my prediction. So anything directly on this line here is my predicted value of y, my y hat. The dots are just my actual numbers. So this dot right here would have a negative residual. Because my actual minus my predicted is going to give me a negative number. This would be a positive residual because my actual is greater than my predicted. So if I have a random scatter plot like this, I'm good to go. All right, so for the next couple questions, we're going to determine if the regression model is appropriate. So looking at this, these are all residual plots, and I want my residuals to look random. Does this look random to you? No, it does not. Or you got a funny definition of random. It looks like a curved pattern, and we don't want that. If I have a curved pattern, I need to consider a different model. So I'm going to say not appropriate. Our regression model is not appropriate. All right, let's look at this. Is this random? I don't know. This is random. This kind of looks like a curve to me. It's not as tight as this curve, but it's a definite curve. So again, my linear model is not appropriate. I want a random scattering of points on my residual plot. All right, so I want you to pause the video and take a second to try C through F. So pause the video and try it. Okay, and we're back. So right here, what do we think? Did we say that a linear model is appropriate or inappropriate? Appropriate. All right, appropriate. It's a random scattering, right? Whew. This one, though, this is inappropriate as a crop top at school. This one is not appropriate. It's got a curved pattern, right? So that will not work. A linear model does not work here. I want random. All right, here, what do you think? I think random. So appropriate. My linear model is appropriate. I can use a linear model. Here, you see that curve. I don't want to see it. Not appropriate. I need to consider a different model. Maybe exponential would work better, maybe quadratic, but linear does not work. All right, so interpreting residual plots. All right, so which graph shows the residual plot for the same set of data? So remember, my dots are my actual, and my line is my predicted. So I can figure out if my residuals are going to be positive or negative based on that, right? So at first I have these two. They're on the top of the line, so I know that they're going to be positive. My actual minus my predicted will give me a positive number. So are my first two dots positive here? They are. Are they positive here? No, they are not. So I'm going to eliminate B. Are they positive here? They are. All right, so I'm down to A and C. I go to my next ones, and I see I have 1, 2, 3, 4, 5 that are all going to have negative residuals. And that's because my actual is less than my predicted, right? So I'm going to have a negative residual for the next 1, 2, 3, 4, 5 dots. So up here at A, I don't go negative, right? This line represents 0. This line represents 0. I need it to go below this axis, and it does not. So A is not. C is. 1, 2, 3, 4, 5. I have 5 negative, and then I should have 1, 2, 3 that are positive, and I do. So this is my residual plot. All right, I want you to go ahead and try example 4 on your own. Pause the video. Okay, this one was a little tricky, but I would go with there does not appear to be a linear relationship because look, we have a bunch of negatives and then a bunch of positives, right? So I have negatives and then positives. That indicates more of a curve, not a line. So you want it to be completely random. All right, and then my last problem here, pause the video. So I went ahead and drew the linear regression lines, and A is my right answer because I have positive, then negative, then positive, just like this residual plot here. So if I drew my line, I have a positive residual followed by negative, and then ending with positive, just like our residual plot here. Positive, then negative, then positive.